Okay, so on worksheet 4, question 4, they give us the molar solubility of cobalt carbonate at 8.0 times 10 to the minus 12. They tell us the solution also has sodium carbonate, and they want us to find the KSP. So again, I know this is a common ion question. There's two different salts. The first thing I have to decide is which one of them is going to get those big 3 steps. The fact that cobalt carbonate is insoluble tells me it's the one that gets the big 3 steps. Sodium carbonate's got sodium in it. I know it's going to be very soluble, so it'll provide the common ion. Another way is the wording of it says find the KSP for cobalt carbonate. So there's 2 clues to say cobalt carbonate gets the big 3. So cobalt carbonate, CO3, breaks down to give you cobalt plus 2 ions and CO3 minus 2 ions. So this is a 1 to 1 to 1 ratio. And because it's a common ion, we're going to create a nice chart instead of just doing a molar ratio, because I know I've got some figuring to do. And I'm going to write my expression KSP is equal to the concentration of the cobalt plus 2 ion times the carbonate of the carbonate minus 2 ion. So that's the first salt. They never told me any of the values of the KSP, but they did give me the value of the molar solubility. Molar solubility is X. I can see that this is a X to X to X ratio, and I know specifically this X. This value is 8.0 times 10 to the minus 12. That's how much broke down. That means this value is 8.0 times 10 to the minus 12, and this value is 8.0 times 10 to the minus 12 from the cobalt carbonate. But there's more, because at the same time we had sodium carbonate, Na2CO3. And because of that sodium ion, this is very soluble. All of it breaks down. This is going to give me 2 of the sodium plus 1 ions and a carbonate minus 2 ion. If this value is 0.1 and all of it breaks down, then I'm going to get 0.2 for the sodium and 0.1 for the carbonate. It's a 1 to 2 to 1 ratio. Looking for my ion and carbon, I can see that sodium carbonate is providing carbonate and cobalt carbonate is providing carbonate. So in addition to the amount of carbonate from the cobalt carbonate, that 8 times 10 to the minus 12, the change is I have to add 0.1 to it. The effect or the equilibrium value then for the carbonate ion is going to be 0.1, and then you'll have 11 zeros before you get to an 8. So this value is going to be equal to about 0.1. This value is unchanging, so let's put these values into the brackets. Concentration of cobalt is unchanged at 8.0 times 10 to the minus 12. Concentration of the carbonate, we're going to be 0.1. A little bit of math, 8.0 times 10 to the minus 12. Multiply that by 0.1. So our KSP then is calculated at 8.0 times 10 to the minus 13. Again, you can tell it's a common ion question because there was 2 salts that had an ion in common.